In this video, we'll be looking at the data science library called Pandas, which provides two key data structures, series and data frames. Earlier, we focused on NumPy arrays, and these again are optimized for homogeneous numeric data that we access via integer indices. So, in a NumPy array, all of the elements have the exact same data type, and as you saw, we were able to perform some pretty powerful operations on entire array objects at once. Now, when you are doing data science studies, they often require more flexible data structures that can support mixed data types, customized indexing that's not necessarily integer based indexing. Often, when you are dealing with massive amounts of data, there will be some missing data along the way, and you need ways to manipulate that properly and handle that. So you are also often going to be dealing with data that is not structured consistently, where you need to massage the data and get it into forms that are going to be appropriate to store in your database or possibly use with some software package for analyzing the data. Now, as we work through our intro to data science on Pandas series and data frames, you're going to see that the NumPy library and the Pandas library are intimately related to one another. The series and data frame data structures from Pandas actually use NumPy arrays underneath the hood. Also, series and data frame object are valid arguments to many of the NumPy operations that we demonstrated to you as part of this lesson. And in addition, arrays are valid arguments to many series and data frame operations as well. Now, this is a massive topic. The PDF documentation for Pandas alone is over 2000 pages. So clearly, I'm going to get in depth into everything about Pandas. I do recommend that if you need to learn more about Pandas, you take a look at Wiz McKinney's book, which I have listed here at the bottom of the slide. So let's begin our introduction to Pandas series, and you can find the documentation for Pandas series at the link that I have posted here. A series is basically an enhanced one-dimensional array data structure that also supports custom indexing. So, of course, with lists that are built into Python and with NumPy arrays, our indexing is zero-based and integer-based. But with Pandas series, you don't have to start from zero for your indexing. And your indices can be non-integers as well. Things like strings, so you can use categorical data. In fact, one of the things we will demonstrate in the series presentation here is the fact that you can initialize a series from a dictionary, and then the dictionary's keys become the indices into that one-dimensional data structure. So Pandas series also offer additional capabilities that will make them convenient for a number of tasks. For example, they can have missing data items, and in those cases, many of the series operations will simply ignore missing data automatically. So now let's go ahead and switch over to our terminal window and begin working with the Pandas series data structure. Now, of course, in order to work with Pandas, we have to first import the library. And in general, people are going to import Pandas for the documentation as PD for short. So we will do that here as well. Now, to save myself some typing time, I'm going to copy and paste code as we go here. So here we are going to create a Pandas series data structure, and the argument to the series constructor here is going to be a sequence of values that you would like to place into the series. In this case, you will give it a list of values that represent three grades, 87, 100, and 94. Now, of course, just like any other variable, we can evaluate the series and get a string representation of it. And one of the things that I want you to notice as I do that here is that it appears that a series is a two-dimensional data structure based on the way it is outputting the string representation of the grade series. In reality, what's happening here is the Pandas series data structure is showing you both the indices associated with each element of the series and the values associated with each element. And then separately, it also gives you the data type of the elements, which in this case is a NumPy data type int64, which is, by the way, a little bit of a hint that underneath the hoods, series is using NumPy arrays to implement some of the functionality. So we have a 3-element grade series here with the values 87, 100, and 94 to get us started. Now we can also create series other ways. For example, for any reason you needed a series that had all elements of the same value, you could call the series constructor with just a single value as the first argument, and then the second argument will help it determine how many values to place into that series. So for example, if I say range 3, I'm going to wind up with a series of 3 elements with indices 0, 1, and 2 respectively. So because I did not assign the result to a variable, it immediately output the string representation of that series. And in this case, notice that because the element values are floating point numbers, that by default series used 64 as the data type of those elements. And again, that's the NumPy float 64 type being used underneath the hood. So let's go back to talking about our grade series up above here. Once you have a series, of course, sometimes you will want to access specific elements within the series. So you can do that by using the square brackets operator, just as we do for lists and for NumPy arrays as well. So for any sequence really. So for example, if I want to see the grades value at index number 0, which is 87, I can evaluate that and get back, of course, the corresponding value. Now there are a whole bunch of descriptive statistics that you can perform on a series. So for example, I can go ahead and invoke methods on the grades object and do things like determine the number of elements in the series. In this case, the count is 3. I can check for the average of those elements. So in this case, the average is 93.666, and that's an infinitely repeating sequence. So it displays a bunch of 6s followed by a 7 at the end. And I can also do other things that we have seen previously, like the minimum or the maximum grades in the grade series. I also have the ability to get the standard deviation. So STD will give me the standard deviation as well. Now it turns out that all of these descriptive statistics can be produced instantly with a single method call. So one of the things that you are going to be doing with Pandas as you start working with larger data sets is using it to get to know your data. And one way to get to know your data is to quickly do a bunch of descriptive statistics, at least if it is numerical data. That would be important. So for example, instead of writing all those individual method calls, I can call describe, and it'll give and it'll go and calculate all of those descriptive statistics for me and a little bit more as well. So again, you see the count, the mean, the min, the max, and the standard deviation as well. And you see these other 3 statistics, which are median values for the first half of the values in sorted order. The overall set of values in sorted order and the second half of those values. So the 50% quartile, as it's called, represents the median of the sorted set of grades. So if I scroll back up here for a moment, you can see that the 3 grades are 87, 94, and 100. And if we were to sort them in ascending order, so if I have 3 grades, the median of those grades is going to be the middle in the sorted set of elements, which would be 94. And then the 25th and 75th quartiles represent the median of the first half of the sorted values and the median of the second half of the sorted values respectively. So again, If I have 87, 94, and 100, there is really no first half because we only have three values. So that it does in that case is it uses 87 and 94 as the first half, and then it finds the median of those two values, which is the average of those two values. So for the 25th quartile, we have 90.5, which is the median of 87 and 94. And similarly, for the second half, we use 94 and 100. And because there is no middle element, it averages those two things together, which gives us the 75th quartile of 97 in this case. Let's go ahead and continue our presentation of working with series. Now, the next thing we want to take a look at is the ability to create a series with the custom indices. So I'm going to go ahead and copy and paste a statement here. And in this statement, you will notice that we have a second argument to the series constructor, which is the keyword argument index. And whatever you supply as the custom index must have the same number of elements as the number of elements in the series. And separately, the index values can be any immutable data type. So in this case, we are using strings which are immutable. The default is to use integers, which are of course immutable, but you can use any immutable objects as the set of indices in your series. So if I go ahead and create the grade series and then display it, now once again you see this two column format where the left column is the set of indices that you can use to access the values in the right hand column. Now you can also create the series that we just showed you above here using a dictionary. So let's say we had a dictionary in which Valley was already associated with the grade 87, Eva was already associated with 100, and Sam was already associated with the 94. So here is the creation of a series using such a dictionary. Notice the dictionary literal that we have here containing the key value pairs. And when I go ahead and create that and then display the string representation, we get the same output as what we got up above. Because again, it is automatically picking off these keys and using them as the indices and picking off the values and using those as the element values in the new series that we just created. Now, once we have a series with these custom keys, we can access the values of a couple of interesting ways. So first of all, we can, of course, go ahead and use the square bracket operator as you would expect. So for example, if I would like to get the grade associated with Eva here, which is 100, I can specify the string Eva and it will give me back the corresponding value. But one of the interesting things about Pandas is that it automatically will create properties on your series object that have the names of your keys if those keys are valid Python identifiers. So, of course, the word valley could certainly be an identifier in Python. So could Eva. So could Sam. Of course, if I have spaces in the names, those would not be valid identifiers in that case. But because these are all valid identifiers in Python, I can do things like grades dot valley and it will give me back the corresponding grade as well. Now, sometimes you may want to know information about the series that you have created. For example, you might want to know what the data type is of the elements. So, of course, if you display the string representation of the series, it will tell you that. But if you simply want to know that without having to display the whole series, first then you can use the dtype attribute for that purpose. And as you can see, the elements have the data type int64. And again, this data type information is something that's coming from NumPy and being exposed to by Pandas as part of manipulating the series. And then separately, once in a while, you may have the need to extract the values from the series as a NumPy array. And so I can also go to the grade series and say, give me the values, and what I get back is actually a NumPy array containing the three elements in this particular series. So let's finish up our introduction to the series for now by creating a series that contains some strings. So I'm going to go ahead and clear the screen again just so that I can work top down. And let me copy and paste in a snippet here where we are going to create a series that contains three string objects. We are not specifying an index for this series, so it is automatically going to use integer zero based indices. So if I go ahead and display my hardware series, now I can see element 0 is hammer, element 1 is a saw, element 2 is wrench. By the way, notice again that just like with NumPy arrays, Pandas series are nicely formatting this into this two column format, and for the values in each element, it's automatically right aligning those values as well. Now, when you are dealing with string based data in a Pandas series, there is an attribute called str, which gives you access to all of the capabilities of Python strings for the elements within your series, and some additional capabilities as well. So for example, if I would like to know for the entire series whether any of these strings contain the letter A, I can write an expression like this. And again, this is for exploring your data. So hardware str gives me access to the string based capabilities for that column, and the method contains comes from the string type in Python. So for every string in this series, it's going to check the string to see whether it contains the letter A or not. And interestingly, what you get back as a result is a series of Boolean values telling you element 0 had an A in it, element 1 had an A in it, but element 2 did not have an A in it. And you can confirm that by looking up at the strings in the original series above here. And of course, one of the other things that you may need to do is massage your data into a format that's appropriate for what you need to do in your application. So for example, one of the things you might want to do is get a series representation of these strings in all one case. So we have uppercase and lowercase letters here, and of course when you are doing string sorting or comparisons and you have different cases, that can result in different comparison values because of the fact that the string character values, the numeric values underneath the hood, are what get used for comparison purposes. So if I go ahead and let's say I want to get uppercase versions of all of those strings, I can just call the upper method, and when I do that, you can see I get back a new series with the uppercase versions of those original strings. And just to demonstrate that it didn't modify the original series, I can go ahead and evaluate that. And we can see those strings were left intact in the original series. So I really did get back a new series object as a result of the snippet number 25 up above. Now that completes our initial introduction to Pandas series.